So I call this factoring second, well, I didn't call it. The book calls it factoring second degree polynomials. A lot of times you'll see people say factoring trinomials, but the trinomial is not just any old trinomial. It's got to be in a certain, it's got to be a certain type of trinomial. And here is the type of trinomial that we're doing. Second degree. Remember we talked about the degrees of things? All right, it's the highest exponent. All right, so what is the highest exponent? It's a second degree, so what's the highest exponent? A 2. A 2, right. It's a second degree polynomial, so it's a 2, which is x squared. So this is basically what our trinomials are going to look like. You're going to have an x squared, then you're going to have something times x, then you're going to have, or a plus something times x, and then a plus just another number. So the c just represents a number. The b represents a number, but is being multiplied by an x, and you're going to have an x squared. In a day or two, we're going to factor something with an a out in front of it, a number other than 1. But today, we're just starting off kind of basic, kind of easier, and just having a 1 in front of the x squared. It gets a little bit tougher if you have another number in front of that x squared, like a 2 or a 3 or a 4, something like that. Everybody with me? Yeah. All right, so this is the kind of stuff that we are going to factor. So before we do that, let's recall some stuff. So let's recall this. What if I had x plus 3 times x plus 4? Okay? And I asked you to multiply those together. Very basic. We've talked about this quite a bit. I think you even had a quiz on it maybe already. What do? What's the word? Foil. It's foil, right. You're just going to foil it. All right? So first, outside, inside, last. So let's do that. So this is nothing new. That's why it's recall. All right? So we're just looking back a little bit. But there's a reason I'm doing this, obviously. So I multiply the first. X times x is x squared. Multiply the outside, which is 4x. Multiply the inside, which is 3x, and multiply the last, which is 12. Everybody with me? Yeah. Okay. Let's simplify it. Add like terms. I got x squared plus what? 7x plus what? Plus 12. All right, so that's my answer. What I want you to do, the reason I did this is I wanted you to see a relationship between these numbers and what you started with. Everybody look at it. Yeah, I'll keep that there. I was going to erase that middle one, but I think that's important to keep there. Look at it. Look at the 3 and the 4, and look at these numbers. Look at that number, and look at that number. What did you do with that 3 and the 4 to get a 12? You multiplied. Okay, that was easy because that's the last part of the FOIL method, right? Yeah. But what about the middle one? That's right. You added these two. See the 3 and the 4? So they add up to be this. The same two numbers multiply to be 12, and they do what? The same two numbers add up to be 7. Okay? So that's kind of old stuff, just doing the FOIL method. What we're doing, the difference in factoring is this. They're going to give you a trinomial right here. Is it in this form? Is it ax, or is it x squared plus something x plus another number? Yeah. So it is that form. It's that second degree polynomial form that we're talking about. So we're going to start with this, and I'm going to ask you to come up with this. All right? So that's the big difference. So it's kind of like we're taking the answer and coming up with the question, kind of, basically. Okay? Does that make sense? So let's do this. This is not an official example, but it's kind of leading us up to it. It's still an example because this is the kind of stuff that you're going to do. Well, I know what I'm doing here. Okay, I'm taking this. I'm just taking this thing. Pretend we didn't know all this stuff. All right? What if I just gave you this? Now look, it's the same as this one, right? So you know that this equals this. So you know what your answer should be. But I'm going to try to take you step by step to figure out how to do that. Well, first of all, look what our answer looked like. this was the question at first, but remember I said we're going to start with this. This is going to be our answer. So what does our answer look like? 2 parentheses, right? So what do you think I'm going to do here? Start with 2 parentheses. Now, this one times this one has to equal what? X squared. So what's that going to be? X and X. All right? Now, let's think a little bit before we do this. This number right here times this number right here has to equal what? 12. And those same 2 numbers, I'm not changing the numbers, those same 2 numbers have to do what? Add up to be a 7. All right? So sometimes this is a thinking game. Knowing your multiplication tables is extremely helpful to do this kind of stuff. And knowing how to add in your head, again, is extremely helpful. Add and subtract. So here's what you can do. After a while, you may not have to do what I'm going to show you right now. All right? It's a little bit lengthy, but it might help you a little bit. So let's take that 12. Like, now I know it's 3 and 4, right? Because I've already done the problem. But let's pretend we didn't know any of this stuff. You're like, what should this be? This could be what? 1 times 12, couldn't it? Isn't 1 times 12 12? Yeah. What else multiplies to be 12? 2 times 6, right? Let's go to the next number, 3. Does 3 go into it? Yeah, 3 times what? 4. Okay. And then the next one would be 4, but we already got a 4 here, don't we? All right, so those are all my possibilities right there. Once I start repeating numbers, all right, that's all my possibilities. So now what I want to do is I want to look at all 3 of these and think, is there which one of those, if I add them together, will I get a 7? Well, 1 plus 12 is not 7, that's 13. 2 plus 6 is not 7, that's 8. But what? 3 plus 4 is 7. So that's the one that's going to work. You with me on this? All right, we'll do this a little bit. But again, after a while, you probably won't have to write all that stuff down. You might be able to just look at it and think in your head what those 2 numbers should be. All right? So what am I going to do here? They both, when you multiply them together, it's positive. When you add them together, it's positive. So both my numbers are going to be what? Positive. And so what can I put here? 3 here and 4 there. Doesn't matter if I put the 3 first or the 4 first. Doesn't make any difference, okay? So x plus 4 times x plus 3 is the same as x plus 3 times x plus 4. Would you agree? Yeah. And that's it. You did it. You factored a trinomial. Yeah, it's not too hard, is it? Now, sometimes, though, they're going to give you some numbers that are a little more difficult. We started off super, super easy. You couldn't get much easier than what we just did, okay? But it's a good starting point, right? And we're going to just build from that. So let's do the first real example in the book. And I think that one right there, I just made that up off the top of my head when I was doing my notes. It wasn't that difficult to figure that out. But this is example 9. If you look at it in the book, and it's example 9. And they all say factor. I'm not going to write it down every single time, okay? But they all say to factor. And here's the first one. It's really not much more difficult. Oops. Squared plus 7x plus 10. All right. I will write it down. Change my mind. Okay, it says to factor this. So first of all, these are all going to be in a little group in your on the homework page, all right? So you kind of know how you're going to start with this. So I'm going to put 2 parentheses, and then I'm going to look at the 10. Now again, I'm doing this with an easy number, and you probably already figured this out. Did you already figure it out, what it's going to be? All right. But there's going to be some numbers eventually that are going to be a little bit tougher. And there's going to be something I'm going to teach you a little bit later that this is going to be really, really helpful. All right, so just bear with me. Let's write all the stuff that multiplies to be to 10. All right, so let's do this first. Put an x here and an x here, plus and plus. Okay, we got to figure out what numbers are going to go here. So 1, right? Because that could be a possibility. There could be somewhere it's the 1 and the number, all right? So I'm going to put 1 times 10. What's the next number? 2. Does 2 go into 10? Sure. 2 times what? 5. Does 3 go into it? No. Does 4 go into 10? No. Does 5? Yeah, but we already got the 5 there, right? So I'm done with my choices. That's really the only thing that multiplies together to be 10 that are nice whole numbers, okay? Nice even numbers. So which one of these, what do I have to do? I multiply them to get this. Both of these work, but I got to add them to equal what? 7. That's right. So I'm looking here. Which one of these adds up to be 7? The 2 and the 5. So those are my numbers in here. So I put a 2 here and a 5 here. I know I took the long way around to get to that. You could have just looked at it and just wrote it down, and that's fine. I'm okay with that. Okay, you should be able to get to the point where you just look at this, put your parentheses, and think in your head, what times what is 10? Those same two numbers add up to be 7. You're like, oh, 5 and 2, right? You only got 2 choices. It's not that hard. Everybody with me on that? Yep. All right. Believe me, you're going to want to watch these easy ones, because this process that I'm trying to get you to think through is going to help you with the ones that are a little bit tougher. Now, this one's just slightly more difficult. I'm going to write it down. I said I wasn't going to write it down every time, but I'm going to. It just will bother me if I don't. So here's another one. X squared minus, here we go. This makes us think a little bit more. Negative 6x plus 8. All right, it's one of our trinomial things, so I'm going to put my 2 parentheses. What am I going to put first? X and x. Now, let's talk about the sign for a second. So this times this is going to be a positive 8. You follow me? So are they both going to be plus? No, because when I add them up, I got to add them up and get a what? No. When I add them up, I get a what? Look up here. A negative 6. So my 2 numbers, when they multiply, have to be positive, but when I add them up, they got to be negative. So what are my signs going to be? Negative and positive? If this was negative and positive, you can't get a positive number for that. 2 negatives, that's it. So I got a negative and a negative. That's the first thing that I would do. You got to think a little bit more on this one, right? So when they multiply together, they multiply to be positive. When they add up to be a negative. So negative times negative is positive, and then a negative plus another negative is negative. Okay? Now, let's think of... We're not doing that. So watch. 1 and what? 1 times what is 8? I'm looking at this number. 1 times what? 1 times 8. So 1 times 8 is 8. Let's go to 2. Does 2 go into 8? Yeah, 2 times what? 4. Does 3 go into it? No. Does 4 go into it? It does, but I already got a 4 there. Those are all my possibilities for 8. Make sense? All right. So which one of these am I going to use? Remember, they both have to be negative. Can I get a negative 1 and a negative 8 to add up to be negative 6? No, because that would be a negative 9, wouldn't it? What about this one? A negative 2 and a negative 4. Yeah, they add up to negative 6, don't they? Negative 2 plus negative 4 is what? Negative 6. So what numbers am I putting in here? Putting in 2 and a what? 4. And that's factored. Now it's factored. So that was a little bit trickier because of the negative. Would you agree? Yeah. But it was kind of the same thing, though, wasn't it? Yeah, I'm almost exactly the same thing, except for the negatives. So that's your answer. So that's factored. Why do we use the word factor? Because those two things are being multiplied together to get what you started with. Okay, what do we call things that multiply together? We call them factors, right? So like 2 times 3. 2 is a factor, 3 is a factor, right? 6 is the product. So this is your product. These are the two things that are being multiplied to get to this. That's why we say factor. You get it? Okay. You guys look bored, probably because these are so easy. But just wait and see. Really, what we're doing today is not that difficult, okay? But there's going to be some things we're doing in the next couple days that you're really going to want to pay attention to. All right, example 11. It says to factor. I'll write that down again. It's kind of the same thing. There we go. This is what we're going to factor. Well, it kind of fits that mold that we've been doing today, doesn't it? So what's the first thing we're going to put down? Not yet. Put the parentheses first, okay? Put the two parentheses. Now, this times this is x squared, so I can put an x here and an x here. Now, let's think about the signs. Not even going to worry about what numbers I'm putting in there. I'm just going to put the signs in there, all right? This times this has to equal negative 12. So if I got two numbers, I multiply them together, and my answer is negative, tell me. One's got to be negative, one's got to be positive. Does that make sense? Yeah, every single time. If I multiply two numbers together and your answer is negative, one has to be positive, one's got to be negative, all right? And it doesn't really matter which one you put it in. I'll put the positive first, and I'll put the negative second. But when I add them up, what do they have to add up to be? Not 1. What's that thing in front of it? It's a negative 1, okay? Always take the sign in front of it. That's a negative 1, isn't it? So I got to figure out what two numbers multiply to be negative 12, and they also add up to be negative 1. With me? So let's write some numbers down. Let's start with 1. 1 times what? 12. But it could be a negative 1 and a positive 12, or it could be a positive 1 times a what? A negative 12. Do you agree? Okay. Because both of these multiply to be negative 12. Is there any way I'm going to get a negative 1 out of that when I add them up? When I add them up, look, negative 1 plus 12. Is there any way that's going to equal negative 1? No, because that's positive 11. This would be negative 11. They do not add up to be a negative 1, so I know I'm not using those. What's the next number I'm going to try? I tried 1. Let's try 2. 2 times what? 2 times 6. But again, one's got to be negative, one's got to be positive, correct? So let's make that one negative, that one positive. And then let's try it this way. When I add those up, do I get a negative 1? No. Negative 2 plus 6 is what? 4. That's not a 4. 2 plus negative 6 is negative 4. That's not a negative 4. So I can't use those. Let's try another number. I tried 1. I tried 2. Does 3 divide into 12? Yeah, 3 does. So 3 times what? 3 times 4. But 1 needs to be negative and 1 needs to be positive. Agreed? So which one of these am I going to use? And it matters. Gianna? The positive 3 and the negative 4. Very good. Because negative 3 plus 4 is positive 1. But what are we trying to get it to be? Negative 1. So positive 3 plus negative 4 is what? Negative 1. So this is the one that I'm going to use. So the positive has to be with the 3. The negative has to be with the 4. Does that make sense? And if you did it, let's do some FOIL method. X times x is x squared. The outside would be negative 4x. The inside would be positive 3x. What's negative 4x plus 3x? Negative 1x. Bam. Exactly what it should be. So the negatives throw a little bit of a monkey wrench into the situation, a little bit of problem. But if you go through our steps, you should be good. Again, I'll say it again. Eventually, are you going to have to write all that stuff down every single time? No. You should just be able to look at it and say, I wonder which numbers multiply to be negative 12 and also add up to be negative 1. I know 2 times 6 isn't going to do it. 3 times 4, oh, 3 times 4. But when they add up, they got to add up to a negative. So the bigger number, the 4, has got to be the negative. That's what's going through my head when I'm factoring these things. Even as a teacher, I can't just look at it and just say the answer. I got to look at it and think a little bit. And all that stuff I just said, that's all going through my head. Everybody see that? And that's eventually what you guys are going to be doing. Tim, I hope you get all this. Yeah, I'm sure. Head on the desk is not the best way to do these. All right, let's do another one. Example 12. It's kind of the same. It's not much different. X squared plus 4x minus 12. Now, you may be able to do this in your head, and if you can, that's fantastic. Do it in your head and just write down the answer. I am not requiring you to show work on this stuff. But if you're still a little shaky on it, right, and you're still not really sure about how to do this, go through the stuff that I've been going through, and I'm going to do that with you. So you know that's going to be an x and an x. Let's go through let's put the sign in here. I like to put the sign in here. I watched a video on this last night because I was trying to get some ideas on best way to teach it. Wondered if anybody had any tricks and stuff. I really didn't see any tricks. But this one guy was listing all that stuff down. I thought, okay, I think that's a good idea because I really hadn't done that before. But one thing he didn't do, which I like to do, is this. Put the signs in here first before you start figuring out what numbers are going to go in here, okay? So they multiply to be negative, but this time it adds up to be what? A positive. So if this times this is equal to negative 12, again, one's going to be positive and one's going to be negative. Everybody got that? All right. So now let's figure out what numbers are going to go here. Well, let's list them, okay? I think this is a good idea. I got this from the guy's video that I watched last night. So 1 and 12. Is there any way I can get a 4 out of a 1 and 12? No. Doesn't matter if I subtract them. Doesn't matter which one's the bigger number or anything. There's no way I can get a 4 out of that. All right? What's the next number? 2 and 6. Yeah, 2 and 6 might work, right? If what? If the 2 was negative and the 6 was positive. When I add those up, I'll get a positive 4. All right, so what's going to go with the positive? And what's going to go with the negative? The 2. And bang, you're done. It's that easy. It's not bad, is it? Guys, I had you guys worrying a little bit, didn't I?
What's the next one after this?
We're going to do factor by grouping, but we're not going to do that today. This is the last one we're going to do today. All right. Oops. Let's write factor x. Oh, my. That's what I need to do, carry around a whistle. Tweet. I think that one lady down the hallway, she uses a whistle all the time. She uses that microphone, or that, what do you call that thing? Bullhorn? You ever see her using that? I see her in the hallway. She's got that bullhorn. You kids need to get to class. And I was like, wow. All right, here we go. Did you see the video clip of William Penn yesterday? Nobody saw it? Yeah. Yeah. Oh, it was crazy. Yeah. I mean, yeah. Well, it's hard to tell. The video was crap. It was all over the place. But I think it was both. Was it guys? Yeah. But I think there were girls involved too. It was hard to see because it's all running around like this, and it's hard to tell exactly. But it was chaos, man. There must have been at least 30 kids involved in this, and it starts at the steps and it goes down the steps, and there's they have a cop at William Penn, you know, what do they call these? Something officer, resource officer, yeah. And he got hit a couple times in the head, and you saw some teachers in there trying to drag kids off, and the girl's what did they say, 6 months pregnant or something like that, and these girls are pounding on her. It's that's William Penn. So anyway, it's not like that every day, but it's like that a lot. I think somebody posted this, whether you believe it or not, I don't know. I mean, who knows if the statistics are correct or not. But I did see somebody post it and said, just this year alone, just from September to now, okay, barely into November, there was 125 violent incidents. Not just people yelling at each other, not just people throwing paper across the hall or something like that, but violent incidents just from September to now. 125. It's crazy at Penn. Yeah. I went to William Penn, but it was not like that. I mean, I saw some fights. Actually, when I was at George Reed. Oh, I forgot I'm recording. I shouldn't be saying all this. Recording. Yeah, I went to George Reed. So I remember this one time when I went to George, I saw several fights. One of my best friends got in a big fight. Anyway, I never got in a fight because I was too little. I'd get creamed. So I never, and I was always a nice person. I always got along with everybody. So I had no reason to fight anybody. But listen to this. I was at George Reed, and give me a pass to go to the bathroom or something. Like, there's nobody else in the hallway. I get out of the room. I hear the door open down at the end of the hallway, kind of about from here to where our door is at the end of this hallway, kind of. And I looked around, and I saw this kid running. He had this white shirt on, and I knew the kid. I think he was on my soccer team. He was running, and his shirt, he had a white shirt on, but it was all ripped up, and it was all red, a lot of red on it. And it was blood. It was his own blood. And this other guy had stabbed him with a knife and was chasing him. And I just walked out in the hallway, and I heard all this rumbling down the hallway, and I stepped back a little bit, and that dude ran right by me, and this other guy is holding a knife, chasing him. That was like, I was in Georgia, that was like 1978, 79, something like that. So it happened back then. It was crazy. The kid did get kicked out of school, thank goodness. He wasn't just suspended, the guy with the knife. But yeah, I don't think he stabbed him, he like slashed him, like this. And I don't know, his arm or something. And he had this big gash on his arm. And I just remember he had this white dress shirt on, and it was just bloody all over. It was crazy. Anyway, I don't know what brought that up. Why did I say William Penn? Somebody said something that triggered that in my head. They didn't say William Penn. They said something else. Videoing something? I don't know. I always like to see where, the bullhorn maybe? Yeah, I don't know. Yeah, maybe that's what it was. That teacher with the bullhorn. I was like, anyway. Sorry about that. Here we go. What if we factor this thing? Now, this is not a trinomial. It kind of looks like the difference of two squares, doesn't it? But is it a difference of two squares? Yeah. Is there anything, like, let's do this. Let's take the 9. What times what is 9? Well, 1 times, let's always start with 1. 1 times 9, this is 3 times 3, and that's it, right? But what would the middle coefficient be, the thing with the x? It would be 0x, wouldn't it? Is there any way that I could get 3 and 3 to be a 0? Is there? Only if 1 was positive and 1 was negative. But this is plus 9. So this has to be either a positive and a positive, or a what? A negative and a negative. Is there any way to get that 3 and 3 to become a 0 then? No, because positive 3 plus positive 3 is positive 6. Negative 3 plus negative 3 is negative 6. There's no way to get a 0. So can you factor this? No. Okay? So you just say it can't be factored. All right? So you just say, some people say not factorable, but just say it can't be factored. Here's a word that this book uses, and I've seen this before. They say it's prime. All right? So when they say it's prime, it means there's no factors. So you can't factor that. There's nothing times anything that equals x squared plus 9. All right? Does it make sense? All right. So sometimes, every once in a while. Now look, I've had students do this all the time. They look at a problem on a quiz or a test. They don't know how to do it. And what do you think they write down? Prime, right? They figured, might as well give it a shot, right? Maybe since I can't factor it, maybe it can't be factored, and they just write prime. Don't just do that. Look at it, make sure you cannot factor it. And I don't think on a quiz or a test I even put one on there that's prime. But there may be 1 or 2 on the homework problems, all right? So just kind of be aware of that. Yes?
No, I was going to ask you if you were going to put down the quiz or test.
Yeah, the quiz or test, well, actually, I haven't made up the quizzes or tests, so I will not put one that it comes out prime on a quiz or a test. Okay, you will always get numbers that will factor, okay? Does that make sense? All right, so you have, what did I tell you to do? I always forget to look. So you are doing 39 to 49, and you're doing all of them. This is a few more than I've been giving lately, all right? So that's how important it is. 39 to 49. And this time, listen to me, you're doing all of them.
Oh, no.
I'm pretty sure. Let me double check. Yep. It's all in capital letters. So there it is. So it's section R5, D, R5D. You're doing 39 to 49. You're doing all of them. But they shouldn't take that long. Eventually, you're going to get into the swing of things. Eventually, you're not going to have to list all these numbers off to the side. You should just be able to do it in your head. You hearing me? Okay, you should be able to think of these things in your head eventually. If this helps, by all means, write it down. But if you don't need it, you should be able to just do it in your head. Yes?
You collect homework already?
I did not, but I will.